Okay, we're going to take some basic notes on the Pythagorean theorem. Most people know that the Pythagorean theorem is a squared plus b squared equals c squared, where a, b, and c are the length of the sides of a right triangle. This only works for a right triangle. A and B are going to be the lengths of the legs, and C is going to be the length of the hypotenuse. So if you don't know the parts of a right triangle, it's important that you learn them. You've got a hypotenuse. Every right triangle has one hypotenuse and two legs. The hypotenuse is always across from the right angle, and it's the longest side of any right triangle. So looking down at a numerical example, we want to solve for x. In this case, the missing side is the hypotenuse. So we're going to start with our formula, which is a squared plus b squared equals c squared. And now we've got some choices to make. We know that the two legs are 5 and 12. It doesn't matter if we put 5 in the a spot or the b spot. As long as it becomes 5 and 12 become the two legs, it doesn't matter which one you make A and which one you make B. So we could go 5 squared plus 12 squared equals c squared. In this case, c is x, so we'll go with x squared, and then you're going to have 5 squared is 25 plus 12 squared is 144, and that all equals x squared. Combine like terms there, and you get 169 equals x squared. So now you've got x squared equals, you've got x squared equals 169. The question is, how do you handle that? So what you're going to do is you're going to take the square root of both sides, and what times what gives you x squared. In other words, if you had a square with area of x squared, what would one of the side lengths be? Well, it would have to be x, because x times x is x squared. So the square root of x squared is x. 169 happens to be a perfect square. The square root of 169 is 13, because 13 times 13 is 169. So at this point, we found our missing side. We have a hypotenuse of length 13. Now, if we come back here to the triangle, we could see that 13 is longer than 5 and 12, and that's because the hypotenuse is the longest side of the triangle. So let's take a look at one more example. So here we go with another example. We've got a right triangle, so we can apply the Pythagorean theorem. A squared plus b squared equals c squared. But this time they give us the hypotenuse, and we're missing one of the legs. So we have one of the legs, 8, so we could fill in 8 for A, and we could fill in x for B, and for C we're going to fill in the hypotenuse 12. And now we've got 8 squared is 64 plus x squared equals 144. You're going to have to subtract 64 from both sides, and when you do that, you're going to end up with x squared equaling 80. And in this situation, you're going to have to square root both sides. So you're going to square root x squared and square root of 80, and we know the square root of x squared is x. And now we have to deal with the square root of 80. So off to the side, we could talk about the square root of 80. Everybody does this a little bit differently, but we could break down the square root of 80 into the square root of 16 times the square root of 5, because 16 times 5 is 80. Square root of 16 is a perfect square, which is 4, so we've got 4 root 5. So now we know that the square root of 80 is 4 root 5. So the answer to this problem is that the leg of this triangle is 4 root 5, and 4 root 5 is an exact answer. We're going to talk more about what exact looks like and what approximate looks like, but if you're ever told to give an exact answer, you don't want to pop 4 root 5 in your calculator, and you don't want to pop root 80 in your calculator. You just want to simplify the radical, and however the radical simplifies, that will be your exact answer. So in this case, the leg of the right triangle is 4 root 5.